Hello learners, in this session we are going to learn about deadlock. So let's begin with deadlocks. A deadlock is a situation in which two processes sharing the same set of resources are effectively preventing each other from accessing the resources, resulting in both programs ceasing to function. Examples: traffic deadlock, resource deadlock. Deadlock handling. Deadlock is a situation where a process or a set of processes is blocked waiting for some other resource that is held by some other waiting process. The following four conditions must hold simultaneously for a deadlock to occur. Mutual exclusion. A resource can be used by only one process at a time. If another process requests for that resource, then the requesting process must be delayed until the resource has been released. Hold and wait. Some processes must be holding some resources in non-shareable mode and at the same time must be waiting to acquire some more resources which are currently held by other processes in non-shareable mode. No preemption. Resources granted to a process can be released back to the system only as a result of voluntary action of that process after the process has completed its task. Circular wait. Deadlock processes are involved in a circular chain such as that each process holds one or more resources being requested by the next process in the chain. Now let's discuss methods of handling deadlock. There are three approaches to deal with deadlocks: deadlock prevention, deadlock detection, and deadlock avoidance. Deadlock prevention. It is the strategy of deadlock prevention to design the system in such a way that the possibility of deadlock is excluded. Indirect method prevent the occurrence of one of three necessary conditions of deadlock: mutual exclusion, no preemption, and hold and wait. Direct method prevent the occurrence of circular wait. Next is deadlock avoidance. This approach allows the three necessary conditions of deadlock but makes judicious choices to assure that deadlock point is never reached. It allows more concurrency than avoidance detection. A decision is made dynamically whether the current resource allocation request will, if granted, potentially lead to deadlock. It requires the knowledge of future process requests. Deadlock avoidance techniques: process initiation denial, resource allocation denial. Deadlock detection. Deadlock detection is used by employing an algorithm that tracks the circular waiting and killing one or more processes so that deadlock is removed. The system state is examined periodically to determine if a set of processes is deadlocked. A deadlock is resolved by aborting and restarting a process, relinquishing all the resources that the process held. This technique does not limit resource access or restrict process action. Requested resources are granted to processes whenever possible. It never delays the process initiation and facilitates online handling. The disadvantage is the inherent preemption losses.